So GE Aviation Commercial Systems is a provider of electric power systems, avionics and flight management systems, nacelle actuation landing gear systems, as well as the Unison engine components and Unison systems. First and foremost, I mean, our industry has always gone through cycles, and each cycle after the downturn goes through a period of expansion which is larger than the period before it. I believe here in the next year or two we'll begin an expansion in our industry which will be the single largest expansion in aviation history. If you look at the baseline demographics of the industry, the growth in worldwide GDP, the growth in per capita GDP, the growth in the emerging markets, we're no longer going to be an industry that is centered around the United States and Western Europe, which is really the only two markets where the industry is mature. The rest of the world is going to come up to the same level of use of aviation that both Western Europe and the United States do today, and that's going to provide for an underlying strength in the growth of the industry. Yeah, so if you think about it, clearly China is just an enormous emerging power, and a very large GDP and a growing GDP, and a country who's been able to sustain large single-digit or small double-digit growth for years, and has had to manage the rate of growth, which is a very high-class problem to have. China is a tremendous market. It's also a tremendous partner, and it's a tremendous growth space for us at GE and GE Aviation Systems especially. So just recently, GE Aviation Systems announced a joint venture with its avionics business with AVIC, which is the largest avionics manufacturer in China. And it's through that joint venture that we will be a part of, that our content will be a part of the COMAC 919 aircraft, which will be China's first real Western narrow-body. That airplane will be an airplane developed in China with many Western partners, and our CFM engine, of which GE is a 50-50 joint venture partner with SNECMA, will also be the engine that powers that aircraft. And we think that aircraft will do very well and be a big part of the aviation landscape in the future. That aircraft is scheduled to first fly between 2015 and 2016, but it'll be China's first foray into a large narrow-body aircraft that could be widely sold to the rest of the world. I think when you think about China, what you have to think about is the relative state of maturity. And so China has not developed a lot of aircraft for a Western market and certified them to Western standards. However, the other thing you have to think about with China is their ability to overcome those obstacles and the rate at which they can overcome those obstacles. I mean, China has basically done in the last 10 years what it's taken our Western nations 50 years to accomplish. And that rate of change and the amount of intellect that they can pour into that requirement for change is tremendous, very, very powerful. Brazil is a fabulous aviation market, and it continues to develop. The Brazilian economy is very strong. I think the Brazilians have done a phenomenal job there. You see the growth, the liberalization of the airlines there, and the growth of per capita GDP, and where they intersect, you see the enormous explosion in air traffic. You know, the largest carriers in Brazil still have 15 to 20% of their passengers as first-time passengers every single flight, and that's very, very powerful. Brazil, a country of 197 million people, is a country that will continue to have a very large aviation demographic. Also, the distances between the cities in Brazil will also demand air travel. The other nations that are extremely important to us as growing nations are what was formerly Eastern Europe, the Eastern European, Central European countries. Those markets to continue to develop, and the economies of those nations continue to be to weather this storm, and will continue to be strong in the future. Countries like Poland, the Czech Republic, etc. And so we're doing work with those nations as well. We have engineering and technology centers in India, in Poland, in Mexico, in China, and we recently purchased an engine manufacturer in the Czech Republic, Walter, which is a 95-year-old engine manufacturer. And through that acquisition, we will be able to grow into an adjacent space for us in GE Aviation in the small turboprop market. Think about it from a standpoint of market maturity, right? So in air transport, Western Europe and the United States are mature markets. In business aviation, Western Europe and the United States are mature markets, but really nowhere else in the world. The business aviation market, general aviation market, is fueled by basically two things: per capita wealth and the security concerns. And so that market is virtually non-existent in many nations of the world where you have a tremendous growth in wealth, and that will be a booming industry in the years to come. I think that the air transport market is just purely a function of where per capita GDP reaches a certain point, and if you have a liberalization of the air transport industry in that country, for instance India, then you just get the explosion of air transport, and that's going to continue to occur. Wealth, the growth of wealth in nations tends to drive people into more urban centers, away from their homes, their historic homes, as it did in the United States and as it did in Europe, and then you create an industry around the travel of those people to and from their homes or between business locations. India, for instance, you have the major markets in Delhi and Mumbai and Bombay and Chennai, et cetera. And there are some very new airports there and some very capable carriers there. And we'll continue to see that growth because, let's face it, there's still 1 billion people in China or in India. Sure. Well, I mean, one of the most exciting things is the work that we have ongoing to try to bring open rotor technology to the commercial narrow-body market. We have a current test with NASA, between GE and NASA, using the NASA Glenn facility in Ohio, and we have an open rotor rig test there. We're learning about new blade shapes, and we're learning about how to make open rotor viable on a commercial air transport aircraft. We flew an open rotor in the mid-'80s, and it's not a matter of being able to fly it, it's a matter of being able, or whether or not it'll be tremendously efficient. It will be tremendously efficient, and we have proven that we can fly it. It's can you make it reliable enough, and can you overcome the installation issues related to a very large fan on the back of the aircraft. But that is tremendously exciting because, when you talk about the advantages of open rotor, you're talking about another incremental 15% lower fuel burn, which is lower carbon emissions as well. So if you can overcome the noise issues and the installation issues, which are not trivial, but that would be an exciting step function. That would be as big a change to airplanes as airplanes going to high bypass fans, for instance. Open rotor would be, think about a conventional jet installation on the aft mounted, typically on the aircraft, and 2 blade sets with 8 blades each, counter-rotating, and the blades being fully articulated. And so those blade sets give you an infinite bypass ratio on the engine, and it dramatically improves fuel burn. And so it becomes a very exciting new technology, new space. I think the other areas that are very exciting are around flight management system and air traffic management, and the use of what's called R&P, or required navigation procedures. And R&P approaches allow us to do continuous descent approaches. Today, when an airplane comes out of altitude, it wants to come out of altitude at a constant rate of descent, at what is the optimum of lift over drag, so the most fuel efficient descent possible. And from high altitudes, you're talking about descents that last 100 miles. Now, today what happens is you get a descent, and you get a descent, and you get a descent, but in between those descents, you level off and you increase your fuel burn, and you are burning more fuel at lower altitudes. In the future, we'll be able to use time-based trajectory and predict the threshold crossing time of the aircraft at the threshold of the runway, plus or minus 5 to 7 seconds. And when you can do that, when you can get that level of control, then you just dramatically improve the efficiency of the system. If all aircraft were capable of RMP today, you could save maybe as much as 12% total worldwide fuel burn. Now, that's a huge number, because air traffic management, will spend billions of dollars to develop a new engine or to develop new technology. The airframers will spend tens of billions of dollars to develop a brand new airplane. And we lose much of that benefit with people flying in the wrong direction, with people doing intermediate level-offs, with people in holding patterns, and things that really diminish the efficiency and the productivity of the airplane. It's all about making the airplane as productive and efficient as possible. And so that's what we're about. I think if you think about the future of aviation, in the times of the downturn, it's always easy to become convinced that aviation's growth was yesterday's phenomenon. It won't be the phenomenon of the future. And I think the reality is that in every economy where you have where a country becomes a developed nation, you see the tremendous growth in aviation. And I think that aviation is an extremely exciting place to be. Innovations still continue at a record pace, and there's still tremendous gain to be had. We are far from being done with innovating airplanes, and they will continue to be innovated to be more and more efficient as we go forward.